Oh, there we go. All right, took a while to start up. All right, so it's homing. Just I think that's what I clicked on was for it to home everything there. So it's not doing anything in particular. Um, all right, so last time we looked a little bit at well, some of the stuff we had printed. Oh, we did the multicolor print. That's what we did. So here's the result of that. I changed the colors a little bit. The first one, like I said, I was printing it on this machine, and this machine is running a firmware called Clipper, which we'll talk about, and we've talked about it on and off. But the problem with that is the way that we did multicolor was that we did two colors stacked on top of one another. You can see there's black with yellow printed directly on top of it. And we inserted G-code straight into the G-code file that generated this physical fleur-de-lis. The problem with that was that Clipper does not recognize all of G-code the way that a Marlin is what most FDM printers are running, and most consumer level printers are running as their firmware. Not all. There's an increasing number that are running something like Clipper or a Clipper version. But the problem with that was that Clipper didn't recognize those particular commands. So we could fix that if we wanted to. We could go into Clipper and add those commands. You know, that's a thing we could do. Or we could use different commands that Clipper does recognize. We could do something like that. But what I did instead is I just sent the same G-code file to a different printer. And one that is running a regular version of Marlin. And this is what we ended up with. So we ended up with, and I did load the filaments into different order. So originally we were printing, this color filament. Now this one is the one that started out on this machine. Actually, it was this way. And you can see where it just went right past our G-code that we wrote in there. It was going to print the whole thing in this copper, satin, or silk filament. I stopped it halfway through when it was obvious it was just going to print the whole thing that way. Other machine printed like this. So you can get some really cool effects by stacking different colors on top of one another. You just have to make sure that whatever G-code you're inserting, or maybe the slicer has a pause at layer, or maybe you're just sitting at the printer and telling it to change filament when you're ready, then you can get some really cool multicolor effects. So that's what we did most of last class. We talked a little bit about a few other things. I showed you one of the AI mesh generators. We'll look at that again a little bit more today. We're still working on this guy. So one of the things, can get that out of the way. One of the things that we need to do is we need the canopy. I want to save that for a resin print. But we need the front landing gear. So I have nothing there, right? Not the catch off. So we need this piece. Now I did find online somebody selling STL files for this piece right here, and they were like $6 or something, which is not crazy for an already made STL specifically for what I want, but that would kind of defeat the purpose. I did get these online, but they were free, so I didn't mind that. And they didn't, making those wouldn't really show you any new thing. Making this one might show you a little bit of new stuff, so maybe well, it will show some, because the wheels, the tires rather, they are going to be similar to these, and they are a rubber. And so in order to have a rubbery material, we need to print TPU. Where's TPU? Get it on the screen. There we go. So I do have some black TPU. This one is white, but it's the one I had handy right now. So TPU is the rubber filament, and it comes in different Shore values. Shore meaning its hardness, elasticity. So this one is on the higher end. It is still flexible. It's pretty, you can't do this kind of thing with a regular PLA filament. You can bend it, but it doesn't really like to bend quite as much as TPU does. There's way more flexible ones. I have some but I'd have to go get it. So we'll just deal with this one. This TPU, or well, TPU in general, and there's also a flexible PLA, which I'm not sure what that is. It's very similar to this though, except it's supposed to print more like PLA. So the TPU that we're going to use is similar to this, although I think it is a little more flexible. It's actually a good material for a variety of things. It's a little bit hard to print, TPU, one because it is flexible, and this is a little bit more of the more rigid kind of TPU. So our printer is a direct drive printer, meaning the feeder is connected to the extruder by a very short filament path. The ones that have the longer filament path, maybe this tube runs all the way back to over there, then those have a little bit harder time printing TPU. The kind that I've got here, that is the more rigid kind, it can be printed on those Bowden tube printers. The really flexible Ninja Flex type of stuff that's like a rubber band, those you almost have to have a direct drive. Even this one is not super direct. There is a little path there. The problem with the long filament path is that as this TPU gets more and more flexible, you have to push it into the tube, and it wants to buckle, and so it buckles all inside that tube, and it can give you a lot of little friction points in there, and it can jam. Another thing that can happen that is annoying but a little bit interesting is on this kind of feeder back here, it can actually, if you go too fast, like feeding the print too fast, it'll actually start coming out the side, and you'll have this big loop of filament just coming out of the side because it's unconstrained here. And these kind of feeders kind of rely on the rigidity of the filament itself to keep it moving forward versus just coming out the side over here and not printing at all. So it is a little bit trickier to print TPU, but it does have high impact resistance. It is flexible, so it is rubbery. It will deform, so you can stretch it. You can kind of control how stretchy it is by the amount of walls and infill percentages that you use. So higher infill, more walls, it's more rigid. Lower infill, fewer walls, it gets more flexible. The part, I guess the TPU stays the same, but the part itself can flex more. It's a little higher abrasion resistance. It's typically chemical resistant. Obviously some chemicals will harm it. I saw a YouTube video. I didn't watch it, so I need to watch to see what they actually came up with. But they were wanting to use TPU as a gasket material, and they wanted to see if fuel like gasoline would eat TPU. I did not watch it to see. I wouldn't really want to trust it as a long-term gasket material, but I assume it could work short-term as a gasket material. It prints a little bit hotter than PLA, so where I normally print PLA around 205, TPU is probably going to be closer to 220 or higher. We already said that it works better with direct drive printers. You typically print it a little bit slower, and so slower is relative to what your printer normally does. On these bed slinger type, where the bed moves back and forth, usually 70 millimeters per second is an okay printing temperature for PLA, and you probably need to drop down to 30 or 40 for TPU. Not necessarily so much that the part is going to be problematic, it's feeding the filament in to the hot end. If you try to feed it too fast, that's when it wants to buckle or run out of the feeder on the side, stuff like that. So it's not necessarily so much that the print is moving too fast, it's that you're having to feed too much TPU into the hot end, and feeding it too fast can be a problem. So you might have to slow it down a little bit from what you normally would. Retraction is a problem. So usually, remember, we use retraction when you're printing and maybe you finish a layer and you got to move to another part, and so you retract the filament really quickly, not that far, just a few millimeters or less depending on the printer. so that it doesn't ooze everywhere. Well, those quick retractions and reinsertions, those can be problems with TPU. So you may have to really lower your retraction speeds. You may have to turn retraction off entirely, which will make it a little stringy. So you might have to deal with some retraction tuning to print TPU. Now again, this particular one, it's not super flexible. Let me get a little more of it out there. But it is, I mean, it's pretty flexible. You can tie it in a knot, you know. So it is going to be a little bit of a problem, but that one is probably rigid enough that it's is doable. Let's see. I'm reading from Canvas here some of this. Oh, what you print it on, like the build plate surface. So this surface is a textured PEI, which is generally okay. PEI, the flat sheets, I would not print TPU on a flat PEI sheet, so one that's not textured, and I would not print it on straight glass, like a sheet of flat glass. TPU can bond too well to those flat, smooth surfaces. So if you're using one of those, you need to do something to work as a interface layer. So either it's textured, like this one. It should come off of this texture pretty easily. You can put glue stick down. I don't normally like using glue stick, but it is useful as a release agent when you're printing TPU on flat glass or on some of the flat PEI sheets, the smooth ones. I've even had, before I knew any better, I printed TPU on a flat sheet of glass that was a picture, it came from a picture frame. And back in the day, you just used whatever you could. So the TPU stuck so well to that when I went to remove the TPU from the glass, it literally pulled chunks of glass off of the piece of panel of glass. So it can bond really well. Another thing you can use the hairspray as a release agent, so you can use that. Blue painter's tape, if you get that wider, the one that's maybe 2 or 3 inches wide, so you don't have to put a bunch of strips down. You can print on top of that, and that is obviously because you can just peel it off of the print bed. That can work as a interface layer between the TPU and the print surface. If you have a printer capable of 2 materials, particularly one that has 2 nozzles, you can use PLA as a release agent. You can do some really cool stuff, not on a printer like this one, but on a printer that has 2 nozzles, or at least a way to flip filaments from one to the other. You can use PLA as a really easy to remove support material from TPU. So maybe we'll try that on I'll try to try it on the bamboo. It doesn't have 2 nozzles, but it does have the AMS where we can feed different filaments. And I think we could probably find some PLA and TPU that printed close enough to the same temperature to do some of that. I'll try and experiment with that. But other materials don't necessarily stick to TPU. So some TPU does print at a hotter temperature. I don't know if this one even has, yeah, this one says 200 to 220. So this one is more like the PLA print temperatures. Some TPU does print at hotter temperatures. So then you do need to worry about the hot ends that are not all metal. I think we talked about all metal hot ends in the past. I don't really remember. But the idea there is that your the internal parts of your hot end, if the tube, the Bowden tube, now this one just has a little short tube. I don't even know if I'd call that one a Bowden tube. If that tube goes all the way down to the nozzle area, some do and some don't. If it does, it's not all metal. If it does not, if it ends, somewhere up in here, then it is an all metal hot end. And what that means is this material is Teflon, this material. Some of it's blue, some of these usually are kind of a creamy white color, but it's Teflon. And Teflon starts to break down around 245, 250 Celsius, somewhere in there. So if you're printing at a hotter temperature, then on a non-all metal hot end, you stand the chance of actually getting this tube to degrade. So you do have to be, that's not true of just TPU, that's true of any material that prints at the hotter temperatures. So I don't remember if we have looked inside an all metal hot end versus not all metal. I'll try and find some for a future, maybe Friday, if I can find the two different styles to show you for sure what we're talking about. Cooling fan, so this layer cooling fan, you usually either have that low or off even. Obviously the lower or off, it might get a little more stringy, and you've already got retraction tuned off or kind of not as much as you normally would, so you might have some stringiness with TPU. I think that gets us most of the information. Oh, TPU is one of the materials that absorbs moisture pretty quickly. So I use a filament dryer. Let me see if I can, I'll just look on Amazon real quick and show you some of these. Let's see. So these kind of things, I use one, well, I think this is the one I currently have. I think. One like that one anyway. Although I think mine is, no, that's the one I'm using right now. This is the one I used for this TPU. So $45-ish. What these do is there's two basic kinds, and most of them now are active. So they actually have a little heater in there, and they will heat up your filament and try to drive moisture out of it. There is a passive kind that is more like a dry box, where you put some desiccant in there and it just kind of keeps the filament wherever it's at. Desiccant won't pull moisture out of your filament, but it'll help new moisture not go into the filament. These that heat up will actually evaporate moisture out of your filament, or at least drive it out. I don't know if they evaporate so much, but this one goes up to 50 degrees Celsius. If you go too hot, then you start worrying about maybe the spool itself melting. So I've had these spools melt. I guess at some point the filament, if you put PLA in there, its glass transition temperature is just over 60 Celsius, so you could end up softening your PLA filament, and you would end up with like a big chunk of PLA. When using AMS, should use to print the same. So with the AMS, so the AMS is a spool holder that holds 4 different spools of filament, and it helps feed them in one at a time to your nozzle. And it is better if you use materials that print at the same temperature, or at least near the same temperature, mainly because let's say you print one at 250 and you print the next filament at 200, you're going to have to purge that 250 out, and then you're going to have to wait for the nozzle to cool down to the printing temperature. If you try printing PLA, for instance, at really high temperatures, it will print, but at some point it's so hot that it's too liquidy, and so it gets really hard to control the flow out of the nozzle. So yes, the short answer is you should print materials that have similar printing temperatures. If you need, like you absolutely have to print a lot of materials that are very different temperatures, you're better off with one of the machines that actually has multiple print heads. Those are usually more expensive though. Also, when using the method you use for the Saints logos. So for this guy, you're relying on the two materials to stick together. And so it's not so much that they're the same temperature, but that they're compatible. Now these are both PLA. These are just both PLA, so they are compatible. But some materials do not stick to each other. PLA and PETG don't stick that well. PLA and TPU don't stick too well. I'll have to look it up, but I do remember seeing a kind of matrix chart somewhere of which materials will adhere to each other and which don't. So it's not so much with this process, not so much the temperature, but do they stick to each other? Because not all of the filaments will actually stick to each other. So what I did with this TPU, and I've had it out since then, but I put it in here, ran it for 8 hours at 50 degrees Celsius, trying to drive out any moisture that might be in here. Because TPU, nylon, ABS, some of those materials really absorb moisture from the air, and living in Louisiana, there's a lot of moisture in the air all the time. So they do make other types here that can go up to hotter temperatures. This is the one I'm looking at some point. This one can go up to 110 Celsius. So that lets you do some different things. So in fact, you can see in their title over here, anneal. So it is possible. You normally think of annealing, maybe you think back to a materials class or something, and it's metal being annealed. You can actually do a similar process to printed objects and anneal them, and make them more stronger than they are straight off the print bed. And one problem with that is they tend to warp a little bit, so you have to constrain them somehow. But I'm looking at this one. I haven't bought this one yet. Probably next year I will try and get one of these. It's way more expensive than the $45 one, and see if these are good to have or not. These type that go up much hotter and can actually anneal the parts. So if you print a lot of materials that tend to absorb moisture, nylon, TPU, ABS, stuff like that, you probably need some. You don't need this guy necessarily, but you probably need one of these little active filament dryers to try and drive moisture out of them. At the very minimum, make you a dry box. You can make a dry box out of a old ice chest or something and fill it with desiccant. You can just buy desiccant. Oh, well, I didn't type, did I? You can buy big buckets of desiccant that you can just put in the container, and it won't pull moisture out of the filament, but it'll keep the environment dry enough that new moisture won't go into the filament. They also make, I also use these. Let's see, these little guys. So in lieu of a dry box with desiccant in it, you could, again, this doesn't pull moisture out, it only keeps new moisture from coming in, but these little vacuum sealer bags, they work pretty well. A lot of times when you buy filament, it comes vacuum sealed, and then these are reusable. This one has a little electric vacuum. I actually think I have one of these over here. Let me see. Yeah. So comes with these little bags. They have a port on them that you have a little. This one has an electric, probably not charged up. Oh no, this one's USB powered. So it has a little electric pump that you put your filament in here, plug this into USB, and then you vacuum out. Maybe we can do that just to see. I don't know if I've used, I gotta make room. I don't know if I've used this particular one. It was still in the box. Dropping bombs over here from the deal. Alright, so there's a little bag. Let's see, I need to find some place to plug in our USB vacuum pump. I think we can plug it in over here. It might reach. It's going to be, yeah, that'll be on the screen, I think. So we would assume that I've dried this, right? You can also, to help out with this, you can get your little some of the desiccant packs, and you can put a little desiccant pack in there. We're about to print with that, so I don't want to seal it up. So it's got a Ziploc seal here, and then I think we just do something like this. Oh, nope. Oh, does this have to charge, or? Oh, so the power port I used there doesn't supply enough power. Let me find another one. Alright, had to go more direct. I was using a accessory port and it doesn't have enough power on it. So that's one thing to be aware of. Let's try this one. So there it is. Kind of slow, but it is pulling a vacuum on this little guy. And assuming that this was dry, and I did just put it in the dryer for 8 hours, 6 hours, something like that, at 50 Celsius. I did that yesterday. So there, and now you've got a vacuum sealed, and it should stay whatever state it was in. It does look like I didn't get this, because I'm losing a little bit of the vacuum. Oh yeah, I didn't get it snapped together right there. So you do have to make sure your seal, your Ziploc seal, is all the way snapped. Mine was, no, it's not snapped there either. So you have to make sure about that. But that's the general process. So we could really vacuum it down. Oh wow, it's doing pretty good. And so then you could store it without having to worry with the dry box issue. So if you have a lot of that kind of filament that you don't print with too often and it just sits on a shelf, you either need to put it in one of these kind of, well, not those, wherever it went, these guys, one of these kind of things, put it in a dry box, or reseal it with one of these little vacuum sealers. Maybe we'll do an experiment here and see, do they stay sealed for a while. I've had some, not this particular set, but I have had some that stayed sealed up for months, I know, between me sealing them and then wanting to use them again. So I'm going to open this one back up so that we can actually get the TPU out. Alright, so that looks doable. Alright, here's our printer. We need to load in this TPU. So we're going to heat, currently there's that copper silk PLA. We'll heat to 205, and we will remove that and put the TPU in. This TPU, I was reading on the label, it says it prints from 200 to 220, so 205 seems like it'll be alright with that. We do need something to print. Let's go get Cura going and see if we can find something to print that doesn't take terribly long to print. I know what we can do. While it's doing heating and Cura is loading, I wanted to show you, I think I showed you Sparked, S-P-A-R-C 3D, which is one of the mesh generators, AI mesh generators. It's one of the newer ones. One of the most popular ones is Meshy.ai. This is what it looks like in general. It does have a paid plan and a free plan. I'm on the free one, so I don't know what all I can do, but or maybe I uses some points. It looks like I have a few points here. So it has a text to 3D, so you can just generate a prompt and it will try to generate that object. Here are some of the objects users have made. They're generally decent. They're not as high quality. Here's a gremlin. They're not as high quality from as the Spark 3D. Although these look pretty nice. Although you can see like this skull helmet here, it looks like there's a whole lot of detail in there. Most of that in this picture is the texture. The actual polygons that make up the geometry are not as detailed. So it can be a little, like this one looks really good, and then it's got holes in it. So you can be a little misleading on the level of detail you're getting. But let's see if we can do a text to 3D, download something, and then print that in TPU. It also do image to 3D. Maybe you have a picture of something you want to copy. I thought about trying to do some of the X30 parts that way. I just don't think that's going to work, so I didn't even try it. But let's do text to 3D. And let's see. I've made some tree stumps. So these I actually used. These were props for a play, and so I used Meshy to generate a tree stump like this one. And so it generated something like this, and I scaled this thing up. I downloaded it, cleaned it up a little bit because there's a few holes or a few like little parts I didn't want. I used Mesh Mixer to do that, and then I scaled it up the size of a 5-gallon bucket, so it looked like a real tree stump, and used the slicer. So in that case I was printed on a bamboo, so I used the bamboo slicer to slice the model into, I don't know, 10 pieces maybe, something like that. Printed them one at a time and glued them all together. I don't know if I have any pictures of the final thing or not, but you can actually use these models that Meshy generates to make some really interesting things. So let's I'm on the free plan. Let's text to 3D. Let's say that we want to make a I don't know, a sitting bulldog. Give it a really open-ended prompt here and see what we can come up with. It said, oh, here we are over here, it's generating. It said it was going to take 1 minute or 10 tokens. I'll just wait 1 minute. Oh no, 10 minutes and 10 tokens. 1 minute and 10 tokens. Because now I only have 90 tokens. I don't know where the tokens come from. Most of these things they give you like every week you get an allowance basically. There's a little bulldog. I don't think he's very printable though. This one doesn't look too bad printable. He looks a little goofy, but it looks like we might could print him. He's mostly sitting down. That one's more realistic, but he's got a weird foot over there. He's sitting on the ground. This guy is very polygonal. So he's got he's like 2 faces or 3 noses or something. So that's kind of weird. Let's go with this one. That one's kind of sad. So we're going to do this one. Let's see, it's asking me now, some of these I can generate a texture for him. I don't actually want a texture. We'll just go with this. You can, if you have the paid plan, you can do more stuff with it. I don't want any of that. So there's our little bulldog. For the most part, I think we could print him, but there's a few things that he's going to have problems with. One, his mouth is actually open, so there's a cavity in there that's going to be filled with support. He's got some weird teeth too. These ears just hanging out like that, those aren't going to print without support. His tongue, not going to print without support, and probably a good bit of this chin. TPU is pretty saggy, so if you don't have support material for TPU and you need an overhang, it's probably going to sag. So let's just download this guy. Let's just download him as a STL file. We had a momentary misconnection there. So this Sculpt GL, this right here, I don't know if you can see the web address for it. It's not Sculpt GL, but you can usually search for Sculpt GL and get there. But the web address is I guess it's stefaneigener.com. This is runs in your browser, so you don't download anything. And this is a digital clay tool. So I don't know if you've used or seen one of those before, but what these do is, like in the middle of my screen right now is a clay ball, and I can sculpt on it like it's clay. And there's a bunch of tools that I can use. Right now I've got a build up tool that builds up material, so, and it's got symmetry turned on. So you can build up and sculpt very organic shapes compared to what you would normally do with SolidWorks. But it will also let me import STL files. So let's get rid of this guy. And let's import our little dog. Where did we save him? I wasn't paying attention. So let me go back to, maybe I never clicked download. I don't remember. All right, yeah, I never. Oh, the internet had messed up on me. All right, so now we've got it downloaded. There he is. So came in at a weird angle, but now we could, if we wanted to work on it. Didn't want to rotate the way I want him to rotate. It's got a weird rotation thing. We could try to manipulate some of these. So the brush I was using, these tools over here are called brushes, or well, they're called tools, but they can do different things. I was using the brush tool, but there's other things you can do too, like drag or move. So this brush size is really large. Let me move that down. Like here, maybe we want to try and move this ear in. I think it's, is it control? Yeah, so control lets me kind of paint this mask on here. Actually, I see a part whoops. There we go. I want to mask off what I don't want to move. Oh. Got to hold control and draw. So let's say I don't want to move his head, so I can color it in. I don't know if I can color in underneath there or not. You know, it'd probably be easier to color the ear and then invert the mask. Would probably be a better thing to do, but I didn't do that. And now when I move, only the parts that are not colored in will move. And I could try to like move his ear closer to his head so that it's not hanging out over there, so that it can print. You know, it gives it a, now it's touching, it's actually touching his head there, and I think that probably can print without support, I think, or at least should be able to. If you hold control and draw outside of it, it erases the mask. His tongue, I could probably, I don't know what to do with his tongue to actually try and get it. I could bring it, you know, we could bring it back. He's kind of weird. Let's, you know, you could do something to try and make it where it could print. Still gonna have trouble with the teeth and all of that, but you could spend some time. I don't want to spend a bunch of time trying to manipulate your model, where something like SolidWorks doesn't let you do that sort of thing. There is a surface tool in SolidWorks that lets you create surfaces a little bit and manipulate them, but this is, once you get better at it, this is way more like actual a ball of clay that you can draw on and work however you want to. I really don't know about those teeth. We probably need to try and close his mouth. I don't know if we can manage to do that or not, but we could give it a try, I suppose. What if we go back to the move tool, make it kind of big, And let's see if we can paint most of this where it won't move. And then see if we can, oops, I didn't want to do that. I erased my mask. Whoops. You can kind of get his mouth to close. Looks like a pig now. But we could spend more time than I'm going to spend on it and get it better. I'm not going to spend a bunch of time though. I just want to show you that, yeah, there are other tools than SolidWorks and Mesh Mixer. There's a lot of variety in ways you might approach problems. Let's say you get him to where he wants. Now we need to export him. Let's save him as a STL. So now he's called, I can't see what it's called, yourmesh.stl. All right. So I think Cura is open by now for sure. Oh, this is my reference I've collected for our part that we need to make. So we'll work on that. Here we go. Let's bring in our yourmesh.stl. It's gigantic, so definitely need to scale it down. Let's scale it by down to 10%. I don't know where it went. Can't even zoom out far enough to see the whole thing. There we go. There's the gizmo to moving. All right, now maybe if I scale him down a little bit. Now he's getting more reasonable sized. All right, still kind of big. Let's make it a little smaller. Well, let's just use this. There we go. All right, so let's say he's still going to have trouble with supports, but let's also, he does have a relatively flat bottom here. Let's just drop him a little bit lower so that it's got a nice flat area to print. And these little reds are showing where support probably needs to be, but we'll pretend we didn't see that. Let's pick, this is a Sane Smart. Do we have Sane Smart? No. So let's just go with generic. Where is generic? TPU. So the 95A is the Shure. This is a 95A. It's one of the more rigid ones. So we'll pick that. We will discard any changes. We do have a 0.4 millimeter nozzle. Now it's got a new set of where it thinks support needs to be. You really need to test it beforehand, but you can use TPU as its own support material. But you can imagine TPU is a little bit floppy, so building up a really thin support with a floppy material might be a little challenging. So we're just gonna, I don't even know if we'll print the whole thing here, so I'm not too worried about it. Let's see what settings it's changed here. So it's printing at 228. This says 200 to 220. Let's go with 220. Print speed, it dropped it down to 50. That's probably a little bit fast, really. But we do have the direct drive on here. It doesn't know that, but we do. It has cooling at 100%. Let's drop that to 50% just to let it really stick to itself. We'll leave support off just because I don't want to deal with the support. Well, let's see what it does. I don't know. Let's slice. How long is this going to take? I'm not very confident this is going to print very well. An hour. Well, let's say that that's what we want to do. Oh wait, we should always preview first. Whoa, okay, look at that. So we're gonna have to remove all of that support. That's gonna be hard to remove. We'll give it a shot. I don't know if it's gonna work very well. So your mesh is what we're looking for. All right, so back over here, we need to get the TPU in here because right now we've got this. This should be heated up. Let me check to make sure I left it heated up. Where's that? Over here. No. Oh, because I don't know why, but it's not heated up. I gotta heat it up. It cooled itself down for some reason. I don't know why. I think Cura had the bed temperature set at off. Yeah, bed temperature is at off on Cura. We probably should find a glue stick or painter's tape. Let me see while it's heating up if I can find one of those quick. Found some glue stick. Let's move this out of the way. It's home. Oh no, it's not home, so we can move it around. I normally don't like putting glue stick on a cold build plate, but I don't want to heat it up either, so we'll put some down just as a little extra precaution on not sticking to the PEI sheet. I don't think it would stick. This one is textured, but it's a light texture, so it might want to stick too well. So let's get our filament out. So our filament is heated up now. When I change filament, what I normally do is I release the tension on it. However, this one you pull this down. Then I push a little bit through and pull it out. So kind of like that, and then pull it out. Okay. Now, what can sometimes be challenging, we got to load the TPU. And since this one is a direct drive, it's not going to be as bad because we don't have to send it very far. But on the Bowden tube printers, it can be a little bit of a challenge to get the TPU through the whole path. We probably should at least try to cut this at a sharp angle. So something got a little point on it, and let's see if we can get it to go through here. Actually, that was not bad at all. All right, so let's home all. While it's doing that, I'm going to load up our file that we just made, if I can figure out where I saved it. There it is. Okay. I'm going to raise the nozzle a little bit. I had to home it in order to be able to raise the nozzle. Looks like I've got some strings from the previous print. And let's extrude and make sure that we've purged out all of the silk. And now we're actually printing TPU. And that it's actually grabbing it. Alright, stuff's coming out. And it's kind of a mixture out. You probably can't see it, but it's a mixture of the copper color and the TPU. It's getting more white as we go. So it started out kind of a tan-ish color. Alright, so that looks very TPU-like. So let's hit print and see what we get. Let's find out. Oh, it's got to heat up a little more because I ran it to 205, but we said to print the TPU at 220. So it's heating up and drooling. Oh, you know, I didn't check in Cura if it turned retraction off or not. Let's just check while it's still on. Oh, and it's way too high. Oh, that's bad. So, for whatever reason, my retraction distance is way too high for this printer. We'll have to work on that. I don't know if it's just with the TPU setting or what's going on there. It's homing. I don't think I have it set up to probe the entire bed. Let's see what it says it's doing. Oh, I must have put that it, so Cura does not have the bed heating up, but apparently my start code in Clipper does. So if I want to change that, I would have to change it in the Clipper side. So there are some times where your machine firmware can override your slicer profiles and vice versa. So if something's not doing what you think it is, one or the other is overriding what you asked for. It's almost heated up. It's at 46. It's got to go to 50. Oh, also another thing, a lot of the printers, most of them, let's say that it's at 50 and I want it to go to 0. It first has to finish the command it's on. So there are different types of commands in G-code. Some of them have to be finished before it goes to the next one. Some of them, a few, it can start it and then like heat the nozzle to 200. It can start it and carry on the rest of the G-code. So this one is set up to where it has to finish it before it goes to the next line of G-code. So even if I told it to go to 0 for the bed temperature, it would still go to 50, then go to 0. Alright, so there's a little blob I'm going to remove. Alright, so let's see. So far nothing's coming out of the nozzle. Alright, so there's our purge starting, so that's good. It looks like it's sticking down pretty well. So we're doing the skirt. It's a little high right here. I'm a little worried. I might raise that corner a little bit. This one looks good. That side looks a little bit like the nozzle's too far from the bed, so I raised that corner of the bed up. No, that's looking decent. It said it's going to take an hour to finish those, so we won't finish during class. It's printing the outline of the support right now. Okay, I think I'll let it run until it's obvious that it's not going to work, and whenever that happens, I'll shut it down, or it'll finish up, and we'll see how hard the there's the retraction. See, this is not so good on it. I should have really reduced the retraction, but since this is a direct drive, it's handling it okay so far, but it's way more retraction than it needs. But we'll see what happens. Also, I did print, you can barely see the edge of it, I did print that fan cover and this thing is much quieter as far as the power supply fan goes. The motors, the stepper motors, are still pretty noisy, but it's not the stepper motors themselves. It's the drivers that are in the control panel under here. I don't know. We could change out that board. I don't know that that's a thing that people do that often anymore. It used to be pretty common to go get a cheap printer and then put a board in it that was a silent driver board, where that whining sound you hear is the stepper motors moving back and forth. You wouldn't hear that at all. And a lot of newer printers come with silent drivers built in. If I can find a nice cheap one, or maybe I already have one, we'll look at changing that board out, just so you know what it is involved. It's actually relatively simple. In this case, it would be a little bit of a challenge because I'd have to reset up that board with Clipper. So I'd have to go through that process again. All right. We're a little early, but this is obviously not going to finish for a while. It's actually printing relatively well. You can kind of see the outline of the little dog. And we'll see how it goes. Friday, we'll be back at 8 o'clock. Not exactly sure what we'll work on, but we'll carry on with maybe some of the modeling for the X30. Maybe we'll start looking at resin printing. That's coming up sometime soon. Also, we do need that, I think, for making the canopy of the X30. So maybe that's what we can work on if I can get it modeled. All right, I will see y'all on Friday.